In this video, we are going to be measuring angles and arcs. So first of all, before we get started, this is what a circle looks like when we're talking about arcs and angles, for example. We're going to be talking about central angles, which are these. They come from the center of the circle. So your vertex for those angles are all going to be at the center of the circle. So our first blank here is to fill in central angle. The central angle of a circle is an angle with a vertex in the center of the circle. Its sides contain two radii of the circle. So a side, for example, of my angle would look like this right here. That would technically be one of the sides of my angle. So that side obviously goes from the center to the outside of the circle, which makes it a radius. All of my central angles, especially like for this picture right here, but every single time you have central angles, they're all going to add up. Even if they're all different, they're all going to add up to 360 degrees, obviously, because a circle is 360 degrees all the way around. So, so we have measure of angle 1 plus measure of angle 2 plus measure of angle 3 equaling 360 degrees. An arc is a portion of a circle defined by two endpoints. Basically, an arc is just a piece of your circumference. So, for example, if my angle is this right there, PQR is my angle, then my arc goes from P all the way to R. That would be one of my arcs. There's actually another arc on the other side going over here as well. So every time you have a central angle, it makes two arcs. Obviously, one of those arcs is bigger than the other, and we're going to talk about that next. So a minor arc would be called, it's a minor arc because it's the smaller of the two arcs. So any small arc that it would be, for example, less than 180 degrees, like this one right here would be a minor arc, because I can tell that that's less than halfway away around the circle. So it's less than 180 degrees. Anytime we're writing that out, we need two letters. So it would be M for measure of arc AB. So measure of arc AB, we're only using two letters because it's a minor arc. Now if it's a major arc, like this, the longer arc would be on this side of the circle. Now we need 3 points, because now we can no longer call it angle or arc AB, because people would think we're talking about going from A to B. So now we've got to call it ADB, and we have to name another point. So we're going to name it with 3 points so that we know we're going through D, and we'll call it ADB. And these are going to be more than 180 degrees as well. Okay, so now a semicircle. A semicircle is an arc with endpoints that lie on the diameter. It goes through the diameter. So, for example, this would be a semicircle. A semicircle is exactly 180 degrees. So I would also write that with 3 letters as well. That way we know we're talking about this side instead of this side. All right, in the same circle or in congruent singles. Let me try that again. In the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So basically it's saying, for example, if this angle and this angle are congruent, then the length from F to G is congruent from the length J to K. So those lengths are congruent if the arcs are congruent, and that should make sense. The addition postulate, this is pretty basic as well. It's basically saying, so arc ZY and YX, if we add those together, we would get arc ZX. So two small arcs make a big arc when added together. Next one, there were 1,125 books sold last week at Sid's bookstore. The circle graph below summarizes these books by genre. The central angle for the romance slice is 69.12. How many of the books sold were romance books? So it wants to know how many of the books were romance books. Just looking at this pie chart and knowing that there were 1,125 books in total. So that's it gets kind of tricky here, but we got to think about it as a fraction. And specifically, I like to tell my class, think about it like if I was testing, scoring one of your tests. If you had 69.12 out of a total 360, remember, because this is a circle, so its total is 360 degrees. If you had 69.12 degrees out of that, you would be able to make a fraction, and that's what I did right here. So I made a fraction, and I simplified it to a decimal. Then I took that decimal, and I multiplied it by how many books were in the store. That was 1,125, and I got 216, and I'll label that books. Okay, moving on to the next one. Same situation here. We have 25.2. You guys can read through that question on your own, but we have 25.2. I put that out of 360. I got a decimal. I got 0.07. And this one didn't ask for how many books or how many votes in this case it was asking for. It was asking for what percentage of the votes did he get. Well, he got 7% of the votes. If 25.2 over 360 equals 0.07, that means this is 7% of that circle. That's 7% of that pie chart. Continuing, arc length. The arc length is a length, it's just basically a section of your circumference. I'm only talking about this right here, for example, if I'm looking at the arc length. To figure this out, we need to set up a proportion, and the proportion looks like this. We have L, that's a cursive L, by the way, that's looking at this one right there. Those two things go together. My arc length is what that's standing for, so that's what I'm trying to find, my arc length. But my proportion set up, it would be the length of that one arc over the entire circumference. So I used pi d for this example. You could also use 2 pi r, but I used pi d. So this length divided by the entire thing would set up a proportion. And that proportion should be exactly the same as if I looked at this angle versus the entire circle's angle, which that's where that x came from right there. So it's part of the outside of the circle divided by all of the outside of the circle. That's that. And then we have part of the angle divided by the entire circle. Or part of the circle divided by all of the circle, if you want to think about it like that. That's the formula that we're going to be using for these questions. So as you can see, I've already got it started for us. It says the radius is 4 yards for this this question right here. So if the radius is 4 yards, then both of these are 4, going from the inside to the outside, right? So if both of those are 4, I went down right away and I made it. I turned it into an 8 because my equation up there said it's pi times diameter. So my diameter would be 8. So pi times 8. This is what we're looking for here. We're looking for L, or the arc length. Specifically, we're looking for the arc length for QSR, which is this side of my circle. So if we're looking for that part of the circle, I need the angle on that side of the circle, and it doesn't give me that angle. It gave me the angle over here. It said it was 170. That means the angle on the other side must be 190, and it looks like it's more than 180 because it's bending backwards, right? So 190 would go there. Then all I need to do is set up my I need to cross multiply, and I should be able to solve for this L that you can see right there. So if I cross multiply, I'll get pi times 8 times 190 equals 360 times L. So now I need to pull out my calculator, so you're going to have to give me a quick second here. I'm actually not going to multiply that pi in, though, because it says it wants us to leave our answers in terms of pi. And basically what that means is we're not going to multiply pi into our answer. It's just going to be a part of our answer. So I'm going to do 8 times 190, and I get 1,520. I'm going to keep that pi where it is and set that equal to 360 times L. That's supposed to be an L. Now I'm going to divide both sides by 360 to get L by itself. So I just need to do 1,520 divided by 360. Ooh, and I got a decimal. I can't remember what that fraction was. For some reason, I was thinking it was 14 over something. Give me a second. No, it's not. I can't remember what that fraction is, so I'm going to have to let you guys try to figure that out on your own. Simplify these numbers. I don't remember what it was, but if it was like 14 over 9, that's definitely not it. But if it was that, I would write my final answer as 14 pi over 9, and then equals L. That's how you would leave your answer. I don't know what that fraction is simplified, and I don't have a calculator that can do that right now, and I don't want to take all your time. So I'll move on right away to the last one here. So for this one, let's see here. I've got my L on the top. I noticed it says the radius is 4 here, so my diameter would be 8. That's why I have an 8 listed down there. That's just coming right from up here. Pi times diameter. And then I have my 360 on the bottom, and then it's saying it wants me to find this arc right there. So that one is 70 degrees, so we'll have to use the 70 for this one. Okay, so now 70 times pi times 8 equals L times 360. 70 times 8 is 560. Times pi, I'm just going to leave that pi there. And then L times 360, I'm going to divide both sides by 360. And that's going to be another fraction that I'm going to have to leave you with. So do the 560 divided by 360. You'll get your fraction. Or if you have time, you can simplify it by hand as well. But, yeah, that's going to be some fraction, something over something, and then your pi can go with it, and that's going to be L. Sorry I didn't have that ready for you guys. You guys, if you have any questions with that, make sure you ask. I'm just asking you to simplify a fraction there, that's all. Thanks for watching.